Hi, in this video we're going to be looking at the electric charge worksheet. And we're going to start off, this is the electricity basics. And first off, what's the source of all electric charges? Well, that's charges or charged particles that are in the atoms. The law of static charge is probably a better way of saying this is what's the law of conservation of charge, is that the total charge in any process is constant. And you will see me write this out as loco C, so law of conservation of charge. So the total amount of charge you have at the beginning has to equal the total amount of charge at the end. Now, this next part, opposite charges. Well, opposite charges will attract, and like charges will repel each other. So opposites attract, likes repel. You've probably heard that in the past. The opposite people attract. It goes with that charges as well. And what charged particles exist in the atom? Well, we already discussed this, but that's the electron, which carries a negative charge, and the proton, which carries a positive charge. And now this next one, why are all atoms neutral? And that isn't always the case, but in their base, common, lowest energy, normal state, atoms are neutral because they have equal amounts of electrons, I'll write that as E, and protons, and P. I'll put a little plus there. Okay. Now, this is, again, we do know, you probably remember from chemistry, you have things called ions. Well, they'll either have too many or too few electrons in there. Okay, but most normal atoms in their base state are neutral. Now, this next part, we talked about rubbing a glass rod with a silk cloth causes it to become charged. Okay, and this is Ben Franklin. He kind of worked with this and came up with the idea. And which material is positive? In this case, the glass rod becomes positively charged. Okay, Ben Franklin set this up, and Ben Franklin thought it was because it was gaining something, it was gaining ether from that silk cloth. In reality, we know that the glass rod is losing electrons. To the silk. Again, there's a transfer of charge due to friction as you rub the two things on there. The silk wants the electrons more than the glass rod does, and so it rips them off. Thus, now the glass rod doesn't have enough electrons, so it has a net positive charge, and the silk cloth has gained those electrons, so it becomes net negative. Okay. Number 3, why is rubbing a balloon on your head allowed to stick to the wall? Okay, and this allows because by rubbing the balloon on there, you are charging the balloon. Okay, and the balloon will generally get a negative charge. Okay, and since the balloon has a net negative charge, it's picked up electrons from your hair. We also know, and this is kind of important to know, that charged objects will attract neutral objects. And that's because you can cause a realignment of the charges on the surface of the other objects, and so they'll get to become, so it's polarized, so that one side of it, well, it's still basically neutral. One side is positive, the other side is negative, and thus we know that opposites attract, causing them to attract each other. All right, number 4, what's an electroscope, what's it used for, and how does it work? All right, for this one, I'm going to slide over because I got to draw a picture. An electroscope is a device that allows us to detect the presence of a charge. And the ones that we use in class look like this, and they have a rod, which I'll put in purple here, or mauve. This rod is allowed to move. And so it detects the presence of charge, because if you bring a charged object close to it, so if I bring a rod close to it, and let's say this rod has a negative charge on it, what's going to end up happening is it's going to cause the negatives that were up here. So initially we had a positive and negative up here, positive and negative up here. Oops, I should get rid of that one blue. Let me phrase it. There we go. positive and negative down here. So I'm just going to put all my negatives in and positive. Now, this is just a symbol of all this. Really, there are millions and millions of charges that are actually going to be moved here. Hundreds of thousands, millions of charges are going to be moved. Okay? I'm just drawing 6. So what happens is when I bring this negatively charged rod, these negatives are going to come down here. They're going to flow through the conductor and slide on down. And that causes there to be the electroscope to become polarized. And so the top half has positive and the bottom half has negative. Well, this rod is allowed to move, and so it will spin and rotate away because these negatives are going to try and get away from each other. These negatives down here are going to try and get away from each other. And so a charged rod or charged electroscope, and I'll put this here, will look like this. And so I'll put all this back in. So here's my positives back up top again. Remember, positives don't actually move. It's just the negatives that do. So the negatives that were up there are now down here. And because they don't like each other, that causes that rod to move. Well, I should probably put in my charged rod because it's close by. Now, if I touch the rod to the electroscope, then it will some of those electrons that are on the rod will transfer down to the electroscope, and the electroscope will have a net charge. And so what the electroscope does is it detects the presence of a net charge, and it also allows us to see whether or not something is positively charged or negatively charged based off of what that rod does when another rod or another charged object is brought close to it. So we're going to work with this in a lab, so hopefully it'll make a little more sense then. Okay. Number 5, what's the charge of pith ball after being touched by a glass rod? We have to remember the glass rod is considered to be positive. And so if it touches it, this is called charging by conduction. And actually you can see that right. What method is used? Conduction. So charging by conduction involves contact, which means they have to touch. And if they touch, then they share the same charge. So initially the glass rod is positive, and it'll share that positive charge. It'll suck some of the negatives off of the pith ball, and they'll both become positively charged. If it's a rubber rod, that rubber rod is negatively charged, and so it will share some of its negatives with the pith ball, and so the pith ball will become negatively charged. And again, this is by conduction, so they have to have in contact. Now, number 6, how does the charged object lose its charge to the atmosphere? Remember that in the atmosphere, in our air, we have water. Okay, and water molecules are polar, which means one side is positive, one side is negative. And so when a water molecule rubs up against something that's charged, it will invariably, generally, once in a while, take a negative off of there. Okay, and so if it's negatively charged, it'll actually take a negative away from it and take it off and move it around somewhere else. So this is due to the polar, this is due to the polar nature, okay, but because of the polar nature of water in the atmosphere. Will allow those excess charges. Because you got to remember, everything invariably wants to be neutral. All right. And our last one, what is Coulombs Law? Coulombs Law is the law that explains the forces between charges. Okay, if I put it as proportionality, they talk about how the force between two electric charges, so the electric force, I'll put it as F sub E, is proportional to the product of the charges and inverse proportional to the square of the distance between them. Now I'm going to jump down here. How is Coulombs Law similar to Newton's law of universal gravity? We talked about how the force of gravity is proportional to, and let me get rid of this, is proportional to the product of the masses over the square of the distance between them. So they have some similarities. They're both inverse square proportionalities, and they're both based off the product of either mass or the charges. Okay. The formula-wise, we have to put in an actual constant there. So the force E, we have to use the electrostatic constant K in order to make this an actual real formula. And that K is the electrostatic constant of 8.99 times 10 to the 9th Newton meters squared over Coulomb squared. Okay. Now, if you use the positives and negatives, okay, if you have two charges that are both positives, that's going to give you a positive force. So if Q1 and Q2 are both positive, then F is positive. and remember, like charges repel. If Q1 and Q2 are both negative, then F is still positive. And so you can say that a positive force will be a repulsive force. Now, if Q1 is positive and Q2, if Q1 positive and Q2 is negative, then your force will be negative. And so opposites attract. So when your force comes out to be negative, then it tells you that it's going to be an attractive force. Okay. So that kind of gives you the identifying the beginning parts of it. There's a lot of theory on this. There's really only Coulombs Law is the only math in this portion right now. So hopefully you can get some background on it. And if you have any questions, come see me. All right. Everybody have a great day. We'll see you later. Bye.